Okay, so we have covered the gain, its plot is very important. There is a slope. Slope is very important. Slope of that line. So all gives a straight line. Remember that all are straight line. That's why. So they are converted into a straight line, which is actually tangent or asymptote to the actual curve. That is why it is called as an asymptotic plot. Okay, so then we covered the integral factor. Integral factor means it is 1 over s. So if you take integration of the integral action, then it gives you 1 over s term. And that is why it is called an integral factor. Okay, so integral factor plays vital role. You will see that in the next topic. And then we have a what is a derivative. So if I have a again dx by dt, the derivative of that is s into x. S comes there. So that's why it is called as a derivative term. So zeros at origin are termed as a derivative term. Okay, then we have covered the simple pole, simple zero. Along they have corner. Simple pole and simple zero. They have the slope with corner frequency. We will now go for one more last one, quadratic form. How to bring that to the Bode platform, and then what is the slope is important. What is the slope? What is the corner frequency? Then the facing. So you have to see. Last one, take the quadratic factor. Quadratic factor maybe it is 4. Quadratic 4. First one is quadratic 4, and then we have a quadratic 0. Okay, we will talk about quadratic 4. The quadratic 0 is very much similar. Only thing is just if quadratic pole is having a slope of minus, then the quadratic 0 will be opposite to that plus. That's all. So we will talk, again take the quadratic 4. Let quadratic form of a pole P. G of x is equal to omega n square divided by s square plus of 2 zeta omega n s plus of omega n square. So standard second order pole. Okay, so standard second order pole is what we call as a quadratic. This is a quadratic form in the standard form. So what we have to do? So find the substitute s is equal to j omega. Bring that to the sinusoidal transform function. Then we have to do some modification. So first put s is equal to j omega. Put s is equal to j omega. G of j omega is equal to omega n square j omega square plus of 2 zeta omega n s j omega plus of omega n square. So this is the sinusoidal transform. When I substitute s is equal to j omega, it gives you sinusoidal transform. It is not in the Bode platform. So to bring above equation in Bode platform, divide both numerator and denominator by omega n square. This is the procedure you have to remember. So you know what is omega n square. So omega n square should be divided throughout by omega n square. So you will get this one, g of j omega. It is 1 divided by, so it is j omega by omega n whole square plus of 2 zeta, 1 omega n cancels with each other, so I get the j 2 omega, 2 zeta omega by omega n, j 2 zeta omega by omega n plus of 1. Note that j square is minus 1, so I get the real part and imaginary part. I write it in the form of real and imaginary part. 1 minus half. This is minus 1, so omega by omega n whole square. I put it in the lower bracket plus of j 2 zeta omega by omega n. So this is the standard Bode plot form. It's very simple. Put S is equal to j omega. Substitute S is equal to j omega in the given quadratic form of pole. Even it is equally valid for 0. Put S is equal to j omega. Then also it is not in the Bode plot form. Remember that. You have to do this. Find what is omega n square. Okay, so you put it in the form of omega n square. If it is 100, say 10 square. If it is 4, it is 2 square. You have to write it. If it is say 2, root of 2 whole square, right? So that is root 2 is your omega. You have to do that. So divide both numerator and denominator by omega n square. So don't worry about what is there here. So I have written it in the standard form. So I got omega n square. So in fact, this is very important. Divide both numerator and denominator, then with omega n square you will get this form. So simply do that. Then separate your real part and imaginary. So write 1 minus of omega by omega n whole square plus of j 2 zeta omega by omega n. This is a factor what I put that. Now log magnitude or magnitude in dB, of the transfer function g of j omega, is. Let me express it in the form of g of j omega dB. G of j omega dB. What is that now? It is nothing but, so log, when I take log 20 log 1, that becomes 0 minus of this one, right? So it is in fact minus 20 log with base 10, and then I have a factor, so it is a root of square of real part, the square of the imaginary part gives you the magnitude. So that means 1 minus omega by omega n whole square plus of 2 zeta omega by omega n, it is whole square. Okay. I got this expression now. This is the magnitude. Magnitude of this is given by, it is the square of the real part plus square of the imaginary part. It is very simple. So We have written that. Now what is that? It is now go further. We are analyzing that at a lower frequency and higher frequency to get the asymptotic or an approximate straight line. We go for this simple analysis wherein at very low frequency what happens to this magnitude, at very high frequency what happens to this magnitude. It will be converted into a very simple straight line. Let me go for that. At very low frequencies, at very low frequency, that is omega by omega n is far less than 1. Or it is omega is far less than omega n. What is omega n? Natural frequency. Remember, so far less than 1. When omega, so lower frequency it is so very small. Remember that you can neglect the term like this one. So can we neglect this term? So can we neglect both the terms? And then remember that I left with only one because these two terms are far lesser than 1 and hence this is approximately equal to 1. So root of 1 is 1. So the magnitude in decibel becomes, it is 0. Let me call this as a, okay, again. That means I got a 0 line. This is a straight line with 0 dB per decade. Equation A is a straight line with 0 dB per decade. 0 dB per decade slope. Okay, this is slope. It's a straight line with 0 dB or 0. So if I in terms of a slope also 0 dB per decade. Now at higher frequency I get one more condition. Okay, one more line. Run at higher frequencies. At higher frequencies, omega by omega n is far greater than 1. Remember, it is this is far greater than 1. It is telling you that this 1 is negligible and also omega by omega n whole square term is also negligible compared to omega by omega n to the power of 4. I am getting that, right? So these two terms are totally negligible when omega by omega n is far greater than 1 or it is simply omega is far greater than omega n. Higher frequencies you can neglect these two terms and can be written g of j omega dB is equal to minus 20 log base 10. This is equal to root of omega by omega n to the power of 4. Or it is equal to minus 20 log base 10 omega by omega n whole square. So then it becomes minus 40 as per the law of log. It is minus 40 log 10 omega by omega n. So this equation is B. Equation B is also a straight line. Equation B also represents a straight line. Where what is that? It is log omega by omega n can be written as log omega minus of minus plus log omega n. Omega n is constant, so that means it is in the form of y is equal to mx plus c form. Okay. So what is it? X again log omega. M is what? So this. So our intention is to know what is the slope of this one. Slope of equation B is, so it is dividing this with respect to log omega. I get the slope is equal to minus 40 dB per decade. Minus 40 dB per decade. Slope is minus 40 dB per decade. Ultimately, I have two lines. Okay, I have two lines there. They intersect at some point. So, we need to know the intersect point. That intersect point is called as a corner frequency. Okay. So, 0 dB line intersect with straight line having slope of minus 40 dB per decade. Minus 40 dB per decade. The frequency at which they intersect is known as corner frequency. Denoted by omega c. Okay, corner frequency. Where they mean? So equation A and B to know the equation A and B. If I do that, so 0 is equal to minus 40 log of omega by omega n with base 10. Okay, or it is log omega by omega n base 10 equal to 0. So taking anti-logarithm both sides, we get omega by omega n. It is 10 power 0 is equal to 1, or omega c corner frequency is exactly at omega n, natural radians per second. Okay? Corner, there are two lines meet at a frequency known as corner frequency or a break frequency. It is nothing but natural frequency. You obtain from that equation, right? So this equation for this one. That's your corner frequency. They meet there. Okay. So what is then phase angle of this is given by? I want to know the phase angle of this. It is nothing but, so because it is in the denominator, so when it goes to numerator minus tan inverse of the imaginary part by the real part. So phase angle of g of j omega is angle g of j omega is equal to, it is minus tan inverse. This is the, I'll write it in the bracket 2 zeta omega by omega n divided by, it is 1 minus of omega by omega n whole square. In frequency domain, usually omega by omega n is written with a letter u. So in some text they take that 2 zeta u by 1 minus omega u 1 minus u square. Anyway, it is the phase angle. Okay, before the sketch, let me go for a quadratic 0. Similar to quadratic 4, quadratic 0 as the form, again it can be in this one s square to zeta omega ns plus half omega n square. Okay, so you have to put s is equal to j omega, g of j omega equal to j omega square plus 2 zeta omega n j omega plus half omega s. Divide throughout by omega, so divide by omega n square. We will get this standard form. Okay. So what is that? I get that g of j omega is equal to in the bracket 1 minus of omega by omega n whole square plus of j 2 zeta omega by omega. Similarly, I can prove that we have a 0 dB line. So for this also, g of j omega equal to 0 for omega by omega n for far less than 1. Then second one, dB. Okay, g of j omega dB equal to 0 for omega by omega n for far less than. As well, another condition is if j of j omega dB is equal to minus 40 plus 40 log omega by omega n, with this stand for omega by omega n far greater than 1. Corner frequency is again 0. Corner frequency omega is equal to omega n. 0 dB and the another line plus 40 dB mean that omega equal omega is equal to omega n. What is the slope here? Slope of this line is plus 40 dB per dB. Yes. At the end, important to note, quadratic pole has the has a two lines, 0 dB line, and another line is with minus 40 dB per decade. Those two meet at a point called as a corner frequency where they meet omega c is equal to omega. From the transfer function you can get there. Same way, phase angle is minus tan inverse of 2 zeta omega by omega n by 1 minus of omega by omega n whole square. So from the transfer function you can easily write that. And then for a quadratic 0, it has 0 dB line as well as the plus another line with a plus 40 dB per decade line. And also corner frequency is omega c is equal to omega n. What about phase angle? Instead of minus, you will get the plus. Okay, phase angle is of g of j omega with respect to quadratic 0 is that plus tan inverse of same thing imaginary part by the real part 2 zeta omega by omega n 1 minus of omega by omega n whole square. Remember this is very simple. When after substituting, what you need to remember, the phase angle is imaginary part. Okay, so many times it is not exactly in this form. Only variable is omega. You will see only one variable omega. You will get some constant here. That is why what do you need to remember? Imaginary divided by the real part gives you the tan inverse of imaginary by real part. Plus for 0, minus for poles always. Okay, that's quadratic. Let me go for the sketch. Go for the sketch here. Let me take a semi-log sheet here. Take a semi-log sheet, and then I have a you can sketch that one, and we will see that. So 0 dB line, gain in dB, gain in dB. Here, remember omega n is your corner frequency. So begin with 0.1 omega n. So 10 times of that is omega n. Then 10 times of this is 10 omega n. Okay, and it goes like 100 omega n. Don't do that here. You can take this one on the line sheet itself. Then we will go for one example. We will do that also with the semi-log sheet later. So you can take in the plan what it is telling. So take it 4 line. This is semi-log. So log scale, it is log omega. So gain versus it is log omega, and then I have to now go for it is minus 20, minus 40, $40 dB line. So take this magnitude versus plot. So 4 vertical lines and of course 4 horizontal lines. So scale you have to take properly 0 dB, plus 20, plus 40, minus 20, minus 40 dB. Now it is time to sketch whatever we got with respect to quadratic. So it is very simple. Whatever the analysis we have done so far, so need to remember ultimately quadratic pole has 0 dB line till the corner frequency of omega c equal to omega n, and later it has a slope of straight line with a slope of minus 40 dB per decade. This is very important. Just all need to remember. It is very simple. So thing is, I have derived that so that you have a justification. So I will go for a summary. You need to remember only that summary. What is now I have to do? Omega n is here. So this is your corner frequency. Omega c equal to omega for quadratic pole. As well, for a 0 I have taken. Draw a 0 dB line till that point. 0 dB per decade line till omega c equal to omega n. This is your corner frequency for this general transform. Same thing you have to identify in the equation where it is given to sketch the Bode plot. Okay. So 0 dB line I have written, and then it is telling that the slope of the line is minus 40 dB per decade. So till minus 40 dB per decade. So generate minus, how to generate? From this one. So minus 40 down, 10 times that is this. So join. Okay, is it clear? Minus 40 10 times of that is this to join. Or anyway you can write minus 40, 10 times, then draw from. I have to draw it from this point onwards. So down minus 40. So 10 times of this frequency is this. So mark a point. If you join this, I get a minus 40 dB. This is corresponding, both together corresponding to a quadratic pole. So this is a quadratic pole. Quadratic pole. Whatever it is. Remember, in fact, it is actual curve is like this, a dotted line. It goes like this. If suppose in your what is that? Laboratory, if you use the command board of sys is the command you need to use there, right? If you use that, you will get a smooth curve, not the asymptotic there. This is actual. So actual. This is asymptotic. Same thing is equally valid for pole also. The simple pole and simple zero. So this is asymptotic. Asymptotic strike, asymptotic lines. Okay, anyway, same thing. Hope you have taken. So that line is very important. This minus 40 generating this perfectly, writing that, understanding that is very, very important. So slope of that line is very important. What do you understand after the analysis of more or less over 3 hours? Just is easy to sketch if I know the slope of that lines. So we will see that. Next, the zero, in other words, it is having the corner frequency is omega c equal to omega 1. 0 dB till omega c equal to omega n again till this point. It has plus 40 dB per decade. So take plus 40 from this point. Plus 40 is this. Mark that one. Go plus 40. Then 10 times is this. Joining that gives you plus 40 dB per decade. Write on that plus 40 dB per decade. This is your quadratic zero. What is important? You need to identify omega n properly for the given transfer function. Right? Omega n. What is omega? At the end, what do you need to remember for the sketch? Usually the sketch is what we expect. Okay, all these analysis culminate into the simple summary of the factors, different factors we discussed. What type of factors we discussed? We'll see that one by one. Say, let me start with, can take this, so factors. I have what is known as, it is factors gain in dB, slope, phase angle, corner frequency, omega c in radians per second, loss one is remotes. Slope in dB per decade. Gain in dB, but slope is dB per decade. Phase angle is in degree. Well, start with gain K. So also it is nothing but constant. How to get the gain K after you bring the transfer function in the Bode plot form only. Should not take gain as it is before converting that into Bode plot form. Remember, should be considered only after you convert any transfer function into standard Bode plot form. So what is mean by? Very simple. So pole or a zero. Simple pole or simple zero must be in the form of 1 plus j omega t. Whereas quadratic form should be in the form of 1 minus omega by omega n whole square plus sub j to zeta omega by omega n. Okay, that's it. Okay, gain of this one is, it is expressed as a 20 log k. 20 log k is base 10. Slope is 0 dB per decade. Phase angle is also 0 degree. We don't have any corner frequency here for this. So go to next. I have a integral factor as well as derivative. Integral or derivative factor. No derivative factor. Any one among this one. This is in the form of, I write j omega to the power of plus or minus n plus for 0. So somewhere plus for 0 minus for 2. If I have n number of 0 or 2, so then this gain is equal to plus or minus. Okay, plus again is for plus or minus 20n log omega with base 10. Plus or minus. Note that if I have 1 for minus 20. So this is important. Ultimately, minus if n equal to 2 poles are there, then 40 minus 40. 1 0 plus 40, right? And then slope is plus or minus 20n dB per decade, plus or minus 20n dB per decade. So again I recall, so you have to identify how many poles you have at origin, whether it is 1, 2, 3 or it is 0, or should be careful, or only or comes. Then I have a phase angle here corresponding to this. It is my plus or minus 90n degrees plus or minus 90 degrees. So I get a term like j to the power of n contributes a phase angle of plus or minus. So you get n be 1 or it is 2 depending on that. Minus for pole again, plus for 0. You have to remember. We don't have any corner frequency. Yes, I don't have any corner. Coming in the remarks term, always initial line corresponding to initial line corresponds to k by k into j omega to the power of plus or minus n. Initial line is always corresponding to this. Again, plus for your derivative factor or a zeroth origin, minus for the pole. So it is always belong to this. Now, what is that? Using that, what is the gain? Gain in dB for this is 20 log k. 20 log k with base n minus plus or minus 20 n log omega is the gain of initial line. Initial line you must take combining together. Okay? So you can take separately. But initial line I have to consider later. I will tell you that. So log k plus or minus 20 n log omega. Now this initial line, second point, initial line passes through. Initial line passes through 0 dB line. 0 dB line at omega is equal to nth root. Nth root of k. 1 k to the power of 1 by n for poles. It is omega divided by 1 over k, 1 over nth root of k for 0 at origin. Poles at origin, zeros at origin. These are the two things need to remember with respect to initial line. Okay, we will start with initial line. Initial line is always, because it doesn't have any 0 dB line. K and this pole at origin are 0. Whereas the simple pole, simple 0 or quadratic, they have two lines. But these two factors, they do not have two lines. So remember that very, very crucial. Let me now go for the quadratic first order factor. First order factor, it can be written 1 plus of j omega t plus or minus 1 plus for a first order 0 minus for first order pole again plus 1 always. So it should be in this form. It should be in this Bode plot form first. So 1 plus j omega t plus or minus omega. So this is in the form of plus or minus 20 log omega. So one is 0 dB line. It has two things. 0 dB line. Second is plus or minus 20 log omega. So that's with a slope of 20. So it has two things. So I will write only this one. Plus or minus 20 n. Here plus or minus 20 dB per decade. So this adds a phase angle of, it is plus or minus tan inverse of, it is omega t, plus or minus tan inverse of omega t, plus for 0 minus for your pole. It has a corner frequency of 1 over t. reciprocal of the j omega term. Is easy to remember and write once you know the transfer function. Bring that to a Bode plot. Okay, that's for both 0. Last one is quadratic factor. Quadratic factors. In fact, it is quadratic factors. You supposed to bring this to standard format. I write a standard format. 1 over 1 minus omega by omega n whole square. Okay. Plus of j 2 beta omega by omega n within the square plus or minus 1 plus for a quadratic 0 minus for quadratic. So what is that? Here also it has a 0 dB line, and second is it is plus or minus 40 log omega. I am writing approximate. That's what it is required. 0 dB line and plus or minus 40 log omega. Okay. So that means the slope is plus or minus 40 dB per decade. 40 dB per decade. This is having the plus or minus tan inverse of here again 2 zeta omega by omega n but 1 minus of omega by omega n whole square should be in standard form. Corner frequency is omega n. Yes, so as I told, the entire whatever the discussions we had over 3 hours at a stretch culminate into a one simple summary. For a sketch, you need to remember only this. You need to remember this. Important is the slope, corner frequency, what is that initial line, how if you learn that much, so you can sketch the entire Bode plot. Any given transfer function. Okay, that's there. We will go for one simple Bode plot and we will take one example. Right, construct the Bode plot. Construct the Bode plot for a unity feedback. Control system. Unity feedback control system having transfer function g of s equal to 2000 s into s plus 1 s plus 100 s plus 100. From the Bode plots, determine one gain crossover frequency. One word crossover frequency. 2. Phase crossover frequency. 3. Gain margin. Phase margin. gain margin, phase margin. Full stop. Comment on the stability of the system. Comment on the stability of the system. We will now see how we can go for. So I hope you remember that you have to take everything according to this. So I need space for that hand. First observe what is the transfer function given. We said the initial line is corresponding to this gain as well as either a integral factor, that means polar origin, or here you have one polar origin. Note. And one more thing, substitute s is equal to j. First step is substitute s is equal to j omega to bring that to sinusoidal transfer function form. Okay. So get that sinusoidal transfer function and check whether it is in the standard Bode plot form. Means derivative factor, especially two things, derivative factor as well as quadratic factor. It should be, derivative factor should be in the form of 1 plus j omega some constant. Always it should be in that form. Is it there? If not, convert it. Quadratic form, it should be in the form 1 minus omega by omega n whole square plus of j 2 zeta omega n. That means some constant into omega form. Only in that form. So you have to bring that to that form. So remember, I have only simple zero or first order poles are there. Nothing other than. First, step 1 is, so go for a solution. Step 1 is put s is equal to j omega to get sinusoidal transfer function. Get the sinusoidal transfer function by substituting s is equal to j omega. And let g of j omega. It is unity feedback control system. H of s is equal to 1 obviously. So g of j omega is 2000 divided by j omega. It is j omega plus 1 or 1 plus j omega. And then it is j omega plus 200, right? Note that. So observe the third factor. Third factor is what is that? First order factor in that pole, right? Pole. This pole is not in. This is 1 plus j omega plus multiplied by 1. So it is exactly in that form, but not this one. Okay, this is not in the form. So it should be 1 plus j omega. Some factor should be there. So what you have to do? Divide this by this 100. So divide both numerator and denominator by 100. Such factors, if you do that, it will be in that factor. To bring above transfer function into Bode plot form. Bode plot form, divide both numerator and denominator by 100. Here it is only 1. So you have to bring all the such factors into Bode plot form. Remember that. It should be in the same form. 1 plus j omega t, whatever t can be anything. 1 plus j omega t form. All the factors. So what happens now? J omega, it is 2000 divided by 100. So here I have J omega. So it is 1 plus J omega, right? Okay. 1 plus J omega. Here, if I divide this by 100, so this becomes 1 plus half. So J factor number 3 should be J omega into T is 1. Here T is 0.01. Should be in that all the factors. Even if you have a simple 0, we call simple 0, right? Simple 0 or first order 0. First order 0 also must be into this form always. Then only it is called as a Bode plot form. Right. What is that again? It is 20 divided by J omega, 1 plus J omega, 1 plus J 0.01 omega. Okay, I will write this. This is exactly the required Bode plot. Okay, that's what we call as a Bode plot. What next? Next is I have to now get the starting frequency. What is the starting frequency? How to get the starting frequency? Starting frequency must be lesser than the corner frequency and the initial line passing through 0 dB line. Write that starting frequency must be assumed. Starting frequency must be assumed lesser than least corner frequency. Lesser than least corner frequency. Least corner frequency and frequency at which initial line crosses 0 dB line. Initial line crosses 0 dB line. This is very, very important. So what I do next after the first step, next step is you have to now write the corner frequency. Corner frequency. Write this at the corner frequencies. What is corner? I get the corner frequencies for only the first order poles. So I write this as 1 plus J omega to the power of minus 1. 1 plus has corner frequency omega c is nothing but reciprocal of this coefficient. So that is 1 by t. We have written over t is 1. So reciprocal of that is 1 radians per second. Simple now. Next, I have another factor. It is 1 plus of j omega 0.01 to the power of minus 1 again. So has corner frequency omega c is equal to 1 over reciprocal of this t is 0.01. 0.01 it is nothing but 100 radians per second. Okay, I got 1 radians per second, 100 radians per second. Fine. So starting frequency must be lesser than what is this? To mark least corner frequency. This is least corner. So least, mark this one. Least corner frequency. And then initial line passes 0 dB line at frequency. So we have derived this one. Omega is equal to k root n root of k. Okay, n root of k. Here n equal to 1. So in this case, see only 1 pole, s to the power of 1. So n is 1. So n here, n equal to 1. So omega crosses 0 dB line at omega equal to k. What is k? K is this. Okay, k is the 20 radians per second. 20. So initial line, only initial line passes 0 dB line where 20 radians per second. Okay. So the starting frequency must be lesser than least among these. So I have already identified one. So 20 is greater than that. So it should be lesser than that. Should not be equal. So it should be taken lesser. Means select the starting frequency as 0.1 radians per second. So let starting frequency be omega equal to 0.1 radians per second. Okay, I selected, so my sketch starts from 0.1. Okay, 0.1 onwards. So that is what? So you have to do this. This is very important. So whether it should be started from 1 or 0.1 decided by these two factors. Least corner frequency, lesser than least corner frequency or lesser than the line, initial line crossing the 0 dB line. Okay, I selected this one. Now I want to find what is the magnitude of initial line at that frequency. So gain J of j omega. Next point, magnitude in dB at omega equal to 0.1 radians per second. So magnitude of this is given. I have written in the remarks initial line as the magnitude. It is always corresponding to this one. Initial line always corresponding to this, whose gain is given by 20 log k. Because it is a pole, it is minus 20. Because one pole is there, n equal to 1, minus 20 log omega. Don't worry, look at that one. Look at the equation given there. Okay? I have given the equation there. Initial line as a magnitude. Given this one, right? Minus 20 log k plus or minus 20 n log omega. So minus because one pole is there. N equal to 1. Only 1 is there. S to the power of n. 1. So it is minus 2. Now substitute the value of k and omega. Calculate that. So k is 20 here. So 20 log 10 20 minus 20 log 10.1. Calculate what it is. What is that value? 46 points? Okay, 46 dB. Okay. So it is 46 dB at point 1. It passes through the 0 dB lines at 20 radians per second. We got two lines with respect to initial line, right? Two lines. So easy to sketch. Anyway, we need to then go for the remaining things. So this is the initial. What is that? You have to Put s is equal to j omega. Of course, you usually do that. You have to bring that to the Bode plot form, that is 1 plus j omega t form. All the poles and zeros must be in that form. Remember, all the zeros as well as poles, first order zeros and poles must be in the 1 plus j omega t form only. We have derived two lines of 0 dB as well as with plus or minus 20 dB for that particular form. Okay, hence that's called as a Bode plot form. You must bring that to 1 plus j omega t. 1 plus j omega t, right? You must. Then only, so then you decide what is k. This is k, not that. This is your k. So whatever you get in the Bode plot form, so that is the k which you need to substitute there. Now, so it indicates that so I have, what are the factors I have? I have a k, I have one integral factor, two first order poles I have to then see what is the corner frequencies and also 0 dB line. We have derived this one. Thereby you can see that. So if I have a pole, n number of pole at origin, it passes the 0 dB line at omega equal to nth root of t. Right? That's what we said. So n equal to 1. So hence it is equal to omega equal to k. In this case, omega equal to k. This is okay. Because of one pole, omega equal to k. What is that k? K is 20. Right? Omega equal to 20 radians per second. Then initial line is given by this factor is very crucial. Right? So substitute that, get the 46 dB at what? In starting frequency 0.1. Next, usually I take this one, I want this one. Usually I prepare one table. Many people never do that. Many days never do this one. So I give you a very simple table wherein you can easily sketch cumulative. Okay, some people draw the Bode plot, separate it and then they add. That is the first method. Second method is write the cumulative. Right? So I go for a cumulative. So again take a table, serial number, write factors, sloping, dB per decade, then cumulative slope, dB per decade, corner frequency in radians per second, revolves. So need to take the factors according to your transfer. Okay? What is that? So say first one is factor is 20, gain is 20. Gain equal to 20 I have. So the slope is 0 dB for that. So add this, so cumulative is 0 again. We don't have any corner frequency for that. So it is available for entire frequency starting from point 1 onwards. So we don't have any. Second, I have the 1 over j omega. That is written as j omega to the power of minus 1. J omega to the power of minus 1. Since minus 1 indicate the slope of minus 20. Easy to remember. Minus 20 dB per decade. Minus 20 dB per decade. Add these two. 0 plus minus 20. Cumulative is minus 20 dB per decade. I don't have anything here. No corner frequency for that. Remarks is that 0 dB crosses. You can take that. The initial line crosses or intersect, crosses 0 dB line, 0 dB line at omega equal to 20 radians per second. Okay, and then initial line has g of j omega dB equal to 46 dB at omega equal to 0.1 radians per second. This is starting point. So these 2 points we need to record with respect to one another, right? So those 2 things are very, very important for us for sketch. So I write that in the remark. So nothing else is there in the remark later. Only those 2 are you have already done prior to this one. Keep it. Keep those 2 things remembered. Okay. Then after the initial line, it is the first order factor or quadratic. Remember, the contribution of the slope is because of a first order factors and slope. First order factors may be polar 0, quadratic also polar 0. I am in general talking. Now what you have to do? You have to now add the factor may be first order or quadratic which has the least corner frequency first. Factor which has the least corner frequency. Note that here this one 1 plus j omega has a corner frequency of 1. I have to add that first. Maybe polar 0, right? First order polar 0 or quadratic form or 0. You have to see corner frequency very good. Now this has the least corner frequency. I have to take that first. Remember, it may be a pole or 0, whatever it may be. In this case, it is a first order pole. I take that. 3, it is 1 plus j omega to the power of minus 1 is the next factor which has a corner frequency of 1. That is why I have taken. Remember, that's very important. Or take the factors in the ascending order of their corner frequencies. So that means least frequency must come first, then next frequency, and it goes on like that. 1. So I have a, because minus 1 it is minus 20 dB per decade. Add these 2, I get minus 40. You have to add cumulative to get minus 40. Note now the corner frequency is reciprocal of this. All I have written here, it is 1 radians per second. Write 1 there. Yes, I have done with this. Last factor I have now. Take the next factor as a 4. Now what is that I have to add? This one. 1 plus of j omega 0.01 to the power of minus 1. It is also a first order pole. So take that. It is also having minus 20 dB per day. So the slope is minus 20 dB per decade. So add these two, minus 20 plus minus what is minus 60 dB per decade. Corner frequency is reciprocal of this is 100 radians per second. We have done this. We have prepared the magnitude plot. So we have prepared a table for magnitude plotting dB versus my plot. What next? I have to now go for the angle, phase angle. Phase angle g of j omega equal to, we have already summarized the gain k contributes 0, nothing will contribute. So if you want you can do 0, 1 pole at item, it contributes minus 90, plus or minus 90 n equal to 1 now. So minus 90 contribute minus 90. Then I have 2 poles, simple poles or first order poles. They also contribute minus tan inverse. Simple to write. Minus tan inverse of imaginary part by what is that? Omega. Minus tan inverse omega. Minus tan inverse. One more also it contributes. Minus tan inverse imaginary is 0.01 omega. 0.01 omega. You now list that. So omega in radian. I have to vary omega in radian. Prepare a table. Geometry. Angle of geometry. Start with starting frequency is 0.1. So in all these things you have to find what is this. Take your calculator and find what is this 0.1. Then it is corner frequency 1. Suppose if it is in between probably the crossing the 180 degree. So closely you will get that one. So maybe it is 2, 5, 10. So check that where it is. Minus 25. Okay, then it's easy. Once if you write the equation, only thing you have to change omega value. Okay, just change omega value and get the 135.5.
Minus 54.5.
154.5. Okay. Minus 1. 71 point. Okay. Minus 2. 180. Exactly. Okay. Then I have to take. Okay. Then yes. 180 I got. This is very important for us. So go for 50 and 100. So last super frequency is 100. So you are in between 1 point and then go for. Minus 205. 0.4. Minus 224. Minus 2. 24.4. Yes, we have now prepared the table, ready to sketch. Go for your log and semi-log sheets. Take your semi-log sheet. In the semi-log sheet, I suppose to plot magnitude in dB versus log omega. In the same sheet, I have to plot phase angle versus log omega, right? So log omega automatically it is logarithmic scale. So the x-axis logarithmic scale. So that always be good. Now, in the semi-log sheet, you can see these things. There is main vertical lines are there, started with 1 right? 2, then of course 3, 4, 5, like that is there at the top, right? You can see that it starts with 1, not 0, right? Remember, you cannot start the frequency with 0. Remember that. That is why I need to know the starting frequency. It should be always with the starting frequency of. So here, write log omega. So we have taken starting frequency of 0.1. Write that 0.1 radians per second. So log omega radians per second. It is in radians per second. 0.1. Okay. Starting point. 10 times of this is 1. Mark this 1. 10 times of this is 10. 10 times of that is 100. You are mark this. Then it is 1000. You need all these things. 0.1, 1, 10, 100. So below you write this. Note that at point 1 it is 46 dB is there. So I take here you have a line like this. Maybe 10 divisions are there, and of course here I take 0 dB. Gain in dB, right? Gain in dB. Start with 0 dB plus 20, 40, 60 dB. Below you mark it as a minus 20 dB. Here minus 40 dB. And then of course I have a here minus 60 dB line is there. Okay, minus 60 times. All of you first mark. So for our reference, generate the minus 20 dB per decade. So I hope you have a ruler draw scale, right? So you can draw that parallel lines. So if you have roller draw scale, so you can generate the minus 20 dB line. I need minus 20, minus 40, minus 60. Cumulative, you see, I need minus 20 line. So do this one. So this is together it is minus 20. Initial line start with minus 20, not 0. Because these together form initial line, right? It starts with minus 20, minus 40, then minus 60. I need those lines. So generate with a thin line minus 20, minus 40, minus. How to do that? So start with 0, down minus 20, changing. This is line is minus 20 dB per decade method. Can strengthen. This is minus 20 dB per decade. If you want, you can write otherwise. It is for our reference. It will not make any marks there. Remember, okay? So then I have a minus 40 dB line. So mark down minus 40. I need minus 40 dB line. Mark down minus 60 and 10 times that gives you minus 60 dB. Draw these lines. Minus 20 dB line per decade line, minus 40 dB per decade line, minus 60 dB per decade lines. Hope all of you have done that. Okay? Is it okay? Simple. Minus 20, 10 times that one. You have to join that. Minus 40 down, 10 times that. You can generate this curve anyway. So it is very simple. Minus 40, minus 10 means minus 10, 10 times. That's all. Okay. Minus 1 dB is minus 1 down or 10 times. Decade is 10 times. Okay. All those things are ready. You are ready. First, go to your table. It says that at omega equal to 0.1 radians per second, the gain is 46. This is not slope gain. So, go to this. This is 0.1 radian, 46. So, here it is 50 somewhere here. Each small division is 2 dB, right? So, you can count this one. Between these,
10 divisions are there. Okay, each is equal to 2, right? So then you can easily count. This is 40, then 2, 3 divisions. So mark that one. So this is your 46 dB per decade. So you can mark that is 46 dB. At point 1, initial line has a 46 dB. So you have marked. Next, initial line is corresponding to the, it says that it passes through omega equal to 20. Initial line. Where is 20? Note that this is 1. After this, here you have 2. Right? Here somewhere you have 2. Mark that point. So, this corresponding to 0 dB, mark that. Joining these, don't join that. So, with a thin line, dotted line, if I join that definitely generate minus 20 dB. Got it? So these are the 2 points corresponding to, so you can join this that line. So these two are parallel lines. So you can use Roland draw scale parallel minus 40, you can draw minus 20. So for me it is not, I don't have it in the instrument, so I am doing rough sketch. So you have to do it properly. So this minus 20 dB and these two must be parallel, right? 20 radians now here. Here the point. Sorry. Easily you can make out mistake. So you have to join this 20 radians. So it passes through 20. So write the dotted line. Here look another rough mark. Our initial line, which has minus 20 dB per decade according to this, it is telling you that it is minus 20 up to 1 radians per second. Okay, corner frequency. Identify the corner frequency. That table telling you that it is minus 20 till 1. Right? So till 1. I want to cross this. So dot that portion till 1. So from 46, I will write a portion dot that till 1 radians per second. That is telling you that, so till 1 radians per second, it is minus 20 dB per decade. Okay? So thick line. So write on that minus 20 dB per decade. All I have to do this till 1 radians per second. Make it thick. Till 100 it is minus 40 dB per decade. Now use your Roland draw scale. Two methods are there. If you are not comfortable with drawing, here also you can draw minus 40 down 10 times. Joining that you will get minus 40 dB line. So use your Roland draw scale and draw a parallel line. So you can now roll this one till this point, parallel line. So draw it minus 40 till what? It is equal to 100. Okay, till 100 it has to go like this. Till 100. Minus 40 dB per decade. Parallel line. Roland draw scale and parallel line. Next it is telling after 100 till the remaining frequency it is minus 60. Take a Roland draw, write a parallel line to this one. So after this it is minus 60 dB per decade. So parallel to this minus 40 dB per decade. என்ன?
So Roland Ross scale is very important. ಅದು ತಗೋಬೇಕು ಇಲ್ಲ ಪ್ಯಾರಲಲ್ ಲೈನ್ ಇಲ್ಲ ಪ್ಯಾರಲಲ್ ಲೈನ್ ಸುಮ್ಮನೆ ನೀವು ಅಪ್ರಾಕ್ಸಿಮೇಟೆಡ್ ಅಂದ್ರೆ the gain will go wrong, so you will be go wrong at